Good morning, students. This is Professor Kiran Poddar, Angadi Institute of Technology and Management, Belagavi. In this session, we are going to discuss solution of linear differential equation by using Laplace transform, where the initial value problems will be taken for consideration. In this session, we are going to derive an expression for Laplace transformation of y dash of t, Laplace transformation of y double dash of t, Laplace transformation of y triple dash of t, and so on. Means what? Here we can see till now we understood how to obtain the Laplace transformation of the given function of t. But here we are going to find out the Laplace transformation of derivatives. First order derivative, second order derivative, and so on. Suppose if we want to obtain a Laplace transformation of first order derivative, that is y dash of t, what will be the solution for this? So Laplace transformation of y dash of t will be taken as s into Laplace of y of t minus y of 0. Here we can see s is a parameter where Laplace transform of y of t means what? It is a function where y of 0 is nothing but the value of that function with initial value of x equal to 0, means initial value. Laplace transformation of y double dash of t will be taken as s square into Laplace transformation of y of t, means it's a function, minus s into y of 0. Y of 0 is the initial value, minus y dash of 0, means derivative of that initial value given where t is equal to 0. Then next, if the given example is having third order derivative, then Laplace transformation of y triple dash of t will be taken as s cube into Laplace transformation of y of t minus s square into y of 0 minus s into y dash of 0 minus y double dash of 0. If you'd like to take its generalization and if you want to make it general and to know how it works for higher order also. If you see these examples, we can see here s, s square, s cube and so on. When it will be taken for nth derivative, then it will be s raised to n. Laplace of y of t, everywhere it will start with the function, basic function only, minus s minus 1. Here we can see s, here it is nothing is there, means it is nothing but s raised to 0. S square, yes, s raised to 0, s cube, s square, s raised to 0. Similarly here, for nth derivative it will be s raised to n, s raised to n minus 1, s raised to n minus 2 and so on till s raised to 0. Then where the function is concerned, here we can see it is a function minus initial value. Here it is a function minus initial value minus first order derivative of initial value. Here it is a function, initial value, derivative of initial value, second order derivative of initial value. So like that it will be taken as s raised to n into Laplace transformation of y of t minus s raised to n minus 1 y of 0 minus s raised to n minus 2 y dash of 0 minus s raised to n minus 2 y double dash of 0, and it will continue till s raised to 0 into y raised to n minus 1 of 0. So this will be the generalization of solution of linear differential equation using Laplace transformation. So to justify these results, let us take one example. Okay, in this example we will be discussing how we can obtain the solution for given example by using Laplace transformation, where the given example is linear differential equation. Okay, so let us see this example which says solve by using Laplace transformation of d square y by dt square plus k square y equal to 0, where the initial values are given, which are nothing but y of 0 equal to 2 and y dash of 0 is equal to 0. This is the condition. Very first, what to do? Before obtaining the solution, we can understand the given example is of first order or second order. It is of second order, means we need to take up to second order derivative where n is equal to 2, means y double dash. Okay, let us see what best can be done. The given equation can be written as, the given equation is d square y by dt square plus k square y equal to 0. Means here it is understood y is a function and t is a variable. Therefore, it can be written as y double dash of t plus k square into y of t is equal to 0. Apply Laplace on both sides. If you apply Laplace on both sides, then it will be equal to y double dash of t plus k square into Laplace transform of y of t is equal to Laplace transform of 0. Now the question comes, what is the meaning of Laplace transformation of y double dash of t? If you see this example, we can see Laplace transformation of y double dash of t is equal to, all the time I told what to do. Don't by heart or don't memorize these formulas. Okay, so follow this result. What happens here? We want it from second order. When we want it from second order, automatically it will be taken as, this is nothing but, for this only I'm talking about this result. This will be taken as second order, means start with s square. Okay, s square Laplace transformation of a function y of t minus, here started with s square, so next will be s. Then comes y of 0 initial value. Okay, it is not yet over till we need to take s raised to 0. S square, s raised to 1, s raised to 0. S raised to 0 is nothing but 1. Then comes y of 0 continuation, that is y dash of 0. Okay, plus k square into, what is a formula for Laplace transform of y of t? Same, because it is not a derivative, it is a function. So Laplace transformation of the function will be taken as it is. Then the Laplace transformation of 0 is equal to 0. Okay. Then by using given conditions, what are the conditions mentioned here? Y of 0 equal to 0 and y dash of 0 is also equal to 0. Sorry, y of 0 is equal to 2 and y dash of 0 is equal to 0. Then substitute these conditions in equation number 1. I'll be calling it as 1. Then equation number 1 becomes s square into Laplace transform of y of t minus s into, what is y of 0? 2. That is 2. Minus, what is y dash of 0? 0. Fine. Plus k square into Laplace transform of y of t is equal to 0. After this, what to do? We have to make a group with common terms. What will be the common term? I'll be taking Laplace transform of y of t is a common term here. If you take this as a common term, then what remains inside of the bracket? Here L of y of t. Here also L of y of t is there. From here a square, from here k square. So it is s square plus k square. Then what is remaining? Minus 2s, which is equal to 0. Then what to do? I'll be taking this 2s to the other end. Then I'll be taking Laplace transform of y of t. Laplace transform of y of t is equal to, very first 2s will go to the other end, it becomes plus 2s divided by, this term comes out, then it is s square plus k square. Fine. And if you transfer this Laplace to other end, then it becomes inverse Laplace. Therefore, y of t is equal to inverse Laplace transform of this. I'll be taking 2 common. Then inside the bracket what it is? S divided by s square plus k square. This is equal to 2 times Laplace inverse of this. S divided by. S divided by means it is cos. It is cos. And here you can see instead of a square, k square is there. So it is k into t. Therefore, Laplace of, therefore y of t is equal to 2 times y of t is equal to 2